So back again just with this, I'm going to quickly go over one more thing. And I thought about it last night. Actually, I thought about it this morning when I realized I hadn't unplugged the batteries. And this has no on and off switch. And it had stopped working, so it had been going all night, even though the light wouldn't have been coming on, because it wasn't in a room that was very noisy, because there's nothing going on in here. So I thought we might just check what the sort of standby current is, or the quiescent current, is that what it's called? When it's not actually doing anything, when it's just sitting still and not reacting. So those batteries must have been okay. It doesn't come on very bright. It's kind of a dark. Oh, almost broke my thing. Alright, I was just about to work on for my other channel. I'm going to turn the lights off for a second. That looks a bit funny. Hopefully the light is coming on. Is it on? It's not going off now. Okay, there it is. Now it's doing 10 seconds. So that was kind of interesting. So yeah, you can kind of see it. Alright, it is going on. It's not going on. It's not. It is. It is. It's just because it's a bit loose. Because it's kind of erratic. So it doesn't. It doesn't. It kind of came on for 10 seconds just then, and then didn't stay on for 10 seconds. Yeah. Okay, now it's doing its thing. Well, anyway, let's just find out how we can do this. So this is just going to be a tutorial about how to test the current, not the voltage. So voltage you test across the circuit. So if I put that on 20 volts, then I can test the voltage across two different parts here. So I can choose, which am I going to choose? Oh, I just realized I was supposed to dig out my oscilloscope, which I dropped down the back of the desk, which I haven't done yet. So that should probably say 3 point something volts. So I'm just doing this across the circuit, so I'm not changing anything. But to measure the current, we're going to have to be slightly cleverer. So these are the two little wires going into the battery. So I'm going to disconnect this one, and I'm going to switch this over to current for now. Which one's the current one? This one here. I've actually never done this. No, I have done it once or twice, but I can't remember. 2 milliamp. Well, I'm pretty sure it's going to be in the range of, well, we'll just start with 20 milliamps. It's probably going to be less than 20 milliamps. I should hope. So we'll put this black one onto here. I think that's not the way I want it. Yeah, it is the way I want to go. No, it's not. Okay, we'll do that one. And which one? It goes into here. Alright, so if I hold it in my hand and then I touch it. So now I'm putting this into the circuit. So this is interrupting and going through the circuit. And we're just going to talk about how you can break your oscilloscope. Not your oscilloscope, your multimeter. It's higher? What? That can't be right. Really? Alright, so when I say something, I get it out of the way. So that's kind of interesting. When you start it off, it jumps down. So when it's not doing anything, so this should be able to, when it's sitting still, wait. I'm gonna wait for the light to go off. Right. So what's that? That's 1.5 milliamps when it's not doing anything. And when it is doing something, it was about 30 milliamps. So when the LED comes on, it's 30 milliamps. So that sounds reasonably, I don't know, I guess that's low. But I guess it adds up because it did go flat overnight. So I should probably get a calculator out and work it. If I was doing this in the video when everything was turned around the other way, I'd write it down and do all this kind of stuff and try and work out how much. Well, if you're doing that, we can kind of work this out. So I don't know what the voltage, what the capacity of a battery is off the top of my head. Isn't it something like 1,000 milliamp hours or 1,200 milliamp hours per battery or something? So you would think that would last for 1,200 hours. So why did the batteries? I guess because they were flat. So they should last quite a while, just doing nothing, sitting around, not being connected to anything. but the batteries that I put in last night, one of them was pretty rubbish and one of them was okay. We're flat in the morning and this wouldn't work. So I don't know, maybe this is actually quite a noisy room at night. Maybe there's something going on that I don't know about. But anyway, so yeah, the only other thing is, if you have it set to current, you don't want to do what you just did then and measure across the circuit, so put them across like that, because essentially there's very little resistance. So when you're putting it within the circuit, so I could draw a little line with a pen that probably doesn't work. So here's, I'm going to draw that, and I'm going to write MM upside down for everybody. So this is your circuit. So this is coming from the battery over here, and then you're doing stuff over here. This is your circuit in the box, and then you're going back around here, and you've inserted your multimeter. I should put an A, the ammeter there. And you want this to be a very low resistance, because you don't really want this to interfere with the circuit as much as possible. So you want everything to go through there, and you want all the resistance to come from over here. And so this is going to have very small effect in comparison to this. Whereas if you have a voltmeter, when you're measuring the voltage, then you're putting it over. It's not too bad. A and V are pretty easy to draw upside down, so that's a good thing. You want it over, like, you put it like, because you're putting it like this, and you're measuring the voltage across these two sections here, whereas the current is going to be the same all the way through the circuit. So if you're doing this, you don't want this thing to have much effect on the circuit. So this is, when you're measuring the voltage, you have a very high current, a very high resistance or impedance, so this doesn't get in the way of the circuit, and only a very small amount, so you're only sampling a little tiny bit of current just to see what the voltage is, because the voltage will be the same across here as it is across the voltmeter, no matter what the current is. So the current will be much higher through here and very, very tiny through here, so it won't have much effect. But of course, if you have it set to amp mode or current mode, and then you put it across like this as a voltmeter, then what will happen is all the current will just go through here, and you might blow the fuse on, because there will be a very low resistance path. So if that turns out to be an ammeter, or measuring the current, then all the current will go straight through here. It will be a very low resistance. It will be a very high current. This will get hot. The fuse will blow. It will be very unhappy. This won't actually be doing anything, and you'll be sad, and your batteries will run out of batteries. But if you actually had the other way around, and you put the voltmeter here in series with the circuit as opposed to being in parallel, then that's kind of okay. That's not going to blow anything up, right? There's just going to be a very high resistance load sitting here, so this isn't going to work. You're probably going to read the battery voltage or all the voltage across here still, but this isn't going to have any voltage, because it's going to be a voltage divider. This will be a high resistance, this will be like a low resistance in comparison, so all the voltage is going across here and nothing's going across here, and this isn't doing anything. And so in that case, it's always, you're going to be a lot easier. It's a lot less likely you're going to blow up your multimeter if you're measuring the voltage. But if you're measuring the current, then don't do that. That's how I understand things. So, but I've almost never felt the need to measure the current. So, but today it seemed like a good time to try, so I did. So thanks for watching, and like, share, and subscribe, and see you next time.